So we need the size of QPW. QPW, let's see, QPW is this angle over there. So if you're going to get an angle here, you can see this angle is like, it's not on the, it's not an angle somewhere at the x-axis. It's just somewhere up there. But then that doesn't mean that we cannot make use of angles at the x-axis to help us. We might as well actually use the angles at the x-axis to help us, because it's more like what we need to be using anyways, you know, regardless of where your angle is. Normally, you just want to single out which triangle you see this angle in. You see it in different triangles, actually. There's the right angle triangle, and then there's this green one here. But then the green one seems to be more useful because the green one has an exterior angle here, you see, of which this exterior angle is an angle of inclination because it's an angle with the x-axis. Now, what do we know about this exterior angle and our triangle here?
Is it about the sum of exterior angle?
The sum of the interior angles, you mean? So the sum of these two angles inside here is going to give us the angle outside. It's because the law says an exterior angle of a triangle is equal to the sum of the opposite interior ones. Meaning this angle here, I don't know what we can call it. We call it PZX. PZX is equal to PTZ. PTZ, I'm writing in black. Writing in this pink is kind of, yeah, it's kind of weird for the eyes. So this is equal to PTZ plus TPW, I mean QPW, which is the angle we want. QPW. We could have named it TPZ also, but it doesn't matter. So that being said, the reason here is just exterior angle of a triangle. Even though it's analytical geometry, you might as well just get used to writing reasons so that it becomes a habit. You know, it's better to just have that kind of a habit because it will help in the long run. So this being written out, we know that all we need is, what do we need? Is the angle, what do we need here? We're looking for this one. So we know that we need to have these two, of which the PTZ is given. PTZ is given, right? This one is given. But then this one, we have to work it out. You see, but then this one is an angle of inclination. Angle of inclination. And then how do we work out the angle of inclination?
10.
The 10 formula. So in the 10 formula, we can have here 10, the angle of inclination, which is PZX, it's equal to the gradient. So we want the gradient of the line here that is cutting the x-axis, of which the gradient of PW, right? We know it was -1. Because when we take the x over to the other side, that's how we're seeing the gradient here. The gradient is just -1. So if the gradient is just a -1, we know that when we get an angle, right, of inclination, always make sure that we get a reference angle first, because a reference angle is just going to be there to help us now, you know, logically see what this angle could possibly be, because this it's an obtuse angle. So the gradient is a -1. So what we need to do here is we will have to say that our reference angle is equal to shift 10, and then we always take this as a positive value. In the calculator, what does that give us? 45.
Oh, the calculator uses 45. Yeah, you're right.
Yeah, so this is going to be 45 degrees. Now you can use this as a way to refer as a reference point on your sketch. So I mean, like, logically speaking, the 45 is this side, you see, because that's the side that's the acute angle. So the obtuse angle there, you can then say therefore P ZX is equal to 180 minus the 45, because angles in a straight line add up to 45. And this is like 135 PZX. So as long as you have PZX, you can then say therefore the 135 there is equal to the 71.57 plus the missing angle, which is like QPW. QPW. And then everything, the numbers on one side, gonna have this, and this is like QPW. 71.57. Let's see what that gives us. 137 minus 71.57. 63.43. And then this is just like QPW. There you go. Which is the angle up here. I mean, it's funny how we ended up getting this, whereas we could have just even used the 45 to say interior angles of a triangle add up to 180. So we could have then just said 180 minus this gives us this. You know, it's just strange. It's just strange how, yeah, dumb things can be done during a question, and then at the end it's like, oh wait, I just did double the work. But it is what it is. Not necessarily double the work per se, but meh. As long as we have the answer, we can move on from this question. So this question was fine, right?
Which one?
I'm saying this question was fine, right?
Oh, I thought you meant the coordinates one. Yes, it was okay. You explained it properly.
Cool. So let's just write this out for the next question. 63.43. That is nice. Let us move on to the next one.